So today I will talk about non-inertial frame of reference. It's a non-inertial frame of reference. So let me recall earlier classes. In the earlier classes we have learned that suppose there is a bus and we are sitting in a bus and bus suddenly starts. So then what will happen? Bus moves in this way and we are also sitting on the bus and we move backward, right? So that means some type of force is acting on our body and we move backward when the bus moves forward. So forward motion means bus suddenly starts. Means there is an acceleration. Or we can say that velocity changes. So when suddenly velocity changes, we feel a backward force on our body and we fall backward. And similarly, when moving bus, there is another case. Suppose there is we are in the bus and bus is moving with the uniform velocity. What does it mean? It means that bus is moving with a constant velocity. But what will happen? But when bus suddenly stops, means we are again applying the force to de-accelerate the motion. So due to the de-acceleration, what will happen? Velocity decreases. Velocity decreases, and what does it mean? It means that velocity decreases means there is again change in the velocity, and because of that change in the velocity, what will happen? Bus stops. It is moving in this way and then suddenly stops. What will happen? Our body falls forward. That's what will happen. So that means, now let us try to relate with the frame of references with all such things. So what will happen? Let us consider bus as a frame of reference. Now what I am considering, now bus as a frame of reference, and it is a moving frame of reference. Initially bus is stationary on the bus stand, so bus station is also a stationary frame of reference and bus is also there, so that means the bus is also stationary and bus stand or the bus station is also a stationary. But when bus starts moving, so that means bus is moving with certain velocity with respect to the bus station. So that means moving bus is basically a moving frame of reference. So let us try to understand it. So that means now what will happen? And as I have seen the earlier examples, that this moving frame of reference, it is applying certain force on the body. It is supposed to apply. So if it is supposed to apply certain force on the object, moving frame of reference, and when it is not moving with a uniform velocity, but it's non-uniform velocity. So yeah, or in other words, I can say that it's a moving frame of reference, but it is an accelerated frame. Accelerated frame. In other words, such frames are said to be non-inertial. Inertial frame of reference. So for this, let us try to develop some mathematical formulation. So consider a frame of reference like this. This is one frame of reference, and say there is another frame of reference, and that frame of reference is a moving frame of reference. Say the frame of reference is like this. It is like this. So suppose this is x-axis, this is y-axis, and say this is z axis, and say it is z prime axis, and it is x prime axis, and it's a y prime axis. So it is a moving frame, and let us call it as S prime frame, and it is moving with the uniform moving with some acceleration. So it is moving in this direction. This frame of reference, it is moving in this direction with the acceleration, say a0. This is the acceleration. So how much distance it have traveled when both the frame of reference is at this point? How much distance this has traveled? Say distance, as we know that distance traveled is equal to ut plus half at square. So distance traveled, this distance traveled is basically, because u is initially both the frame of reference is at rest, then it is basically 0, and it is moving with the uniform acceleration. What does it mean? It has traveled this distance. So that means I can say that, and say if it is a0, then this distance is said to be half of a0 t square. This is the distance which this frame of reference have moved in the t time, right? And let us call this point is O, and this is O prime, and suppose there is a some point in somewhere here, and the point will be here. Let us assume that it's a P point. When it is seen from this, say it is at a vector r, and when it is seen from this moving frame of seen from this one, then this is and say it is r prime vector. So if I try to look at it, then what will happen, that OP vector is equal to OO prime vector plus O prime P vector, and the point will remain the same. Now let us try to do one thing. Let us apply triangular vector addition here. So that means R vector is equal to R prime, this is plus half it is 1 by 2 a naught t square plus R prime. Then what does it mean? So let us now because we are interested to find out the force, so for the force we need to first of all find out its derivative with respect to time, to find out the velocity, and then to find out the acceleration. So for that, let us take a derivative with respect to time. So dr upon dt, so d upon dt of half a naught t square, and the a naught is a constant. A naught is a constant because this moving frame of reference is moving with the uniform acceleration. So that means a naught is a constant plus dr prime over dt. So I can write down it as a dr vector over dt is equal to it is a naught t plus dr prime by dt, again taking its derivative with respect to time. So if I again take its derivative, it will become d square r over dt square is equal to, it is a naught as it is, plus dr prime over dt. So what is it? It is d square r over dt, means it is the acceleration of the particle when it is moving with respect to the stationary frame of reference. And what is it? It is a naught is the acceleration, uniform acceleration of the moving frame of reference. And what is this? This is the acceleration of the particle when it is seen from the moving frame of reference. So that's what we are getting here. So if I multiply both sides by mass, then ma is equal to ma vector is equal to ma naught vector plus ma prime. So what is it? We can simply rewrite down it as like this. Ma prime plus ma naught ma. So what is it? Force acting on the particle when it is seen from the stationary frame of reference, and it is the force acting on the particle when it is seen from the moving frame of reference, and it is the force due to moving frame of reference. Force due to moving frame of reference, and let us call it as F naught. So from here I can write down it as a Fs naught is equal to, so F minus F of naught. So that's what we are getting here. So let us try to relate it with our example which we have discussed here. So say bus suddenly moves, means bus is initially at rest. So that means bus is if initially at rest, then what will happen? This Fs will be 0. But when it suddenly moves, then what will happen? This moving frame of reference applies some force on the bus, but in the opposite direction. And the force is, that means a additional force is acting on the system because of the acceleration or because of the non-inertial frame of reference, and such type of forces are said to be a fictitious forces. Such type of forces are said to be a fictitious forces, and that, as we know that Newton's laws are not valid here, because what Newton's laws suggest that? Newton's laws suggest that if we are not applying any force on the system, then what will happen? It will not change its position of the rest of the motion. But here what is happening? Here the thing is that here what is happening means a fictitious force is acting on the system because of the non-uniform motion or the acceleration of the moving frame of reference. So that's what is happening here. So let us try to understand it. Suppose I am putting some pen here, say it's like this, or let me do one thing. Yeah, this is pen I am putting over here. So when I move it like this, say it is here, when apply some force over it in this direction, then initially it goes in this direction, in the opposite direction, and when it suddenly stops, then it goes in the opposite direction. Say it is like this, right? So that's what is happening here. So that's all for this lecture. In the next lecture I will talk about that what will happen if we are in the rotating frame of reference, and that is moving with the uniform velocity, and because of that the new forces came into existence. I will talk about that later on. So thanks for watching this lecture.